at shapes of distributions. So histograms can take many different shapes. This is one of the most important shapes. It's our normal distribution. And you'll note that it's symmetrical. So if we were to draw a line right in the middle and fold it on half, it would be pretty even on both sides. It will never be quite as perfect as this one, but approximately symmetrical. The shape will kind of look like a bell, and is called a bell curve, in fact. And this is the shape that you're looking for. And note that these distributions go to infinity. So they can go in either direction as far as it can possibly be. So you assume that they go to infinity. And you'll notice that it's unimodal. The mode is the most common value, and you'll see that there's only one peak. So the most common value is here, and there's only one peak. There's not another hump occurring anywhere else. So when we do any of our data analysis throughout this chapter, we are always looking for our data to have a normal distribution. Statistical tests are inherently reliant on the data distributed in this normal distribution. However, we can have different shapes. Sometimes we can have a bimodal shape. Once again, the mode is the number that occurs most frequently in the data set. And if it's bimodal, that means we have two peaks. We have two places with greater number of ages. So for example, maybe this data would represent, let's write chart 3, and it would be ages of people in a daycare center. And so ages would be along here, and we might have a lot of people in the preschool category. I'll write preschool here. And maybe we also have a lot of people in their 30s or so who are serving as the care providers. So we'd have a lot of people here, we'd have a lot of people here, we have two modes. This is called a bimodal distribution, and that's a term you'll want to become familiar with. Bimodal. We can also have a multimodal distribution. Maybe in this case we have 3. An example of what this might represent is the ages at which major life changes occur. So there's maybe a major life change when you maybe graduate from college or whatever in high school and start your career. Maybe that's what that represents. Maybe there's another change when you start your family and have children. Maybe there's another change when you retire. And those are maybe ages at which major life changes are likely to occur. Those are bimodal and multimodal distributions. We can also have something we call skew. Skew refers to an asymmetrical distribution with one tail or the other longer. So here's our symmetric distribution. Here's one that's right skewed. That means it has a long tail to the right. The data are clustered up on the lower end. Here's one that has a left skew or a negative skew. The tail is long to the left. So the left or the right refers to where the tail is pointing. So you can just draw a little arrow on that tail to remember whether you're looking at left or right skew. In this case, the data will represent a distribution that has a lot of values that are different from the majority of values. And this is an important concept that we'll be working with in our next chapter. And you may recall that our income distributions in the video we watched had a right skew. It looked something like this. Most of the people had incomes that were lower, but a few people had incomes that were quite a bit higher. And so if income is along the bottom, that would be a right skewed distribution. Now, this along the bottom is, let's say, the level of wealth. the income or the level of wealth along the bottom. The example that we had in our big distribution that was actually a left skewed distribution, you'll recall that that was the distribution of the wealth. So across the bottom, it was the amount of individual wealth that people had, rather than presented the same way as income. We also have a histogram of earthquake magnitudes. There are many earthquakes on this earth, and with these many earthquakes, most of them are small. Most are small, but there are a few, just like there are a few really rich guys, there are a few earthquakes that take on a much greater magnitude. And so this again is a right skewed or a positive distribution. A left skewed distribution is one that goes in the opposite direction. And in this case, my example is the number of practice quizzes completed at the end of Unit 1. So let's imagine that this is our distribution. We have some who maybe only completed 1 or 0, but most students completed a lot of them, and a few students completed all of them. So this is what I would expect the distribution to look like. I hope it looks like everyone completed all of them, but it might be different from that. And here we have another histogram. This is, again, look at the shape, this negative distribution, and we'll talk about this in a moment. This is a negative distribution. It's the age of death of Australian males. We might build the case that it's negative and bimodal because of this little peak here, which is looking at infant death. And of course, when infants are just born, they're very vulnerable. And so we do have a higher rate of deaths also right at infancy. But other than that, we have most people living up until their 80s. We have some who die at younger years. This is what that distribution looks like. If we were going to describe this, we might say it is negatively skewed. And we might also suggest that it's bimodal. We have some effects that can change the look of the graph. We can have what's called a ceiling effect. And if you think of this as the ceiling, kind of a sideways ceiling right here, then we know that 100% is the highest score a person can get on the test. And it looks like it was an easy test because a lot of people reached that 100% mark. So we weren't able to get any information about how much the students knew beyond that because there was a ceiling effect. There wasn't any way for students to demonstrate that they knew more than that. The test was too easy. A test that is too hard might have a floor effect, that is, the data piles up on the floor. And so in this case, you can see that a lot of students got 0. They couldn't demonstrate anything less than that because there's the floor. The floor is at 0. And this is another way that a data set can be truncated or cut short. Another way we can describe information distributions like this is through kurtosis. And the simple way that we think of kurtosis is referring to the peakedness or flatness of a distribution. So we would say then that high kurtosis is had in this blue distribution, and note how tall the peak is. And we would say that light tails are in this purple distribution. And I emphasize this because what's important about this distribution isn't so much that it's tall or short. What's important about it is where the distribution is spread. So when we have a distribution with low kurtosis, that means it's a flat distribution. And so the values are all in the center. And so look how thin the tails are. Look how thin the tails are. That's the important thing, because when we're thinking about this distribution, we would have fewer values in the tail, and it would make a difference when we're working later in the term with statistical significance. Likewise, this kurtotic distribution with the high kurtosis, or this high peak, well, the most important thing about this is that the data are like all squished into the center, And so since they're squished in here, some of them ooze out the bottom into this kind of heavy tail. So we could say this. There we go. So histograms aren't always normally distributed. Now you'll notice this is not perfect like the one we saw. And if we were going to assess the shape of it, we would just be sort of tracing the outline. We're not tracing it exactly. And so this would be normal. Here you can probably see that we have a unimodal distribution with a lot of negative skew. I think I might have this written in. Yes. Skew left, unimodal, we might say. You know, we might be able to say something like this has high kurtosis also. We could possibly say it does seem a little tight in the middle and the tails seem a little light, so we could say it's kurtotic with light tails. And I think we might be able to say the same thing here. This is a positive skew, but the tail seems pretty light. So we might be able to say this is also kurtotic. Here we have what's called a uniform distribution. There's not really a clear pattern to it. All of the frequencies were fairly even. And so we would call this a uniform distribution. Let me think of an example for this. If everyone has about the same number, let's say that we live in a socialist country, then income would be very similar for each individual. Income in a socialist nation, or we'll work on more examples of this a little bit later when we're doing our problem solving. Here we have a bimodal distribution, prefix bi meaning two, and here is our multimodal distribution. So you now are ready to take your first attempt at the quiz, and we're not doing this in class, so I hope you have success with it.